The average American man consumes 10 grams of sodium each day. Suppose that the sodium consumption of American men is normally distributed with a standard deviation of 0.9 grams. We're going to suppose an American man is randomly chosen and X is going to be the amount of sodium consumed. We're going to round all numbers to 4 decimal places. So part A says, what is the distribution of X? We know that it's normal, which is why we have the N here, because that was given to us in the problem. Now, in our notation for normal distribution, we have to put the mean and the standard deviation, which was given to us in the problem. We have 10 grams was the average, and we have 0.9 grams as the standard deviation. So that's just setting up our notation. Part B says, find the probability that this American man consumes between 10.4 and 10.9 grams of sodium per day. So we want to find the proportion of men that fall between those two values for their salt consumption. So when we look at a picture of this, you know 10 is in the center. 10.4 is going to be a little bit past 10, and then 10.9 is going to be a little bit past that. So we're looking for the area under the curve between those two values. We can use the Normalcdf function for that. We put the lower bound, which is, whoops, oh no, that's right. We have the lower bound, which is 10.4. We have the upper bound, which is 10.9. Then we have the mean, which is 10, and the standard deviation, which is 0.9. And we put that in our calculator, and when we round it to 4 places, we get 0.1697. So that's our answer to part B, 0.1697. For part C, it says, the middle 10% of American men consume between what 2 weeks of sodium? So if we look at our graph, we're looking for the middle 10% for those values. We know 10 goes in the middle, and we're looking for the 10% in the middle. We're going to have to use inverse norm because we're trying to find the two values that gives us that 10% in the middle. But when we use inverse norm on the calculator, remember inverse norm, we have to plug in the percentile, and the percentile is the percentage that lies under the graph to the left of the point that you're looking for. So if I look for this point first, I need to know what the percentage is to the left of that, because that's what we need to put in on the calculator. Well, if 10% is in the middle, and I know that the entire graph has to be 100% underneath that curve, then 90% is left over in each wing, which means 45% is in each of these wings. We have 10, although it's not proportioned correctly, but 10% is here, and then we divide it up equally on each side because the graph is symmetric so that it all adds up to 100. So now I can use inverse norm, and since I'm looking for this X right here that I just boxed, first I want to put in 0.45 for my percentile, and then I put in my mean, which is 10, and my standard deviation, which is 0.9. Now when I do that, I get 9.8869. So that's this value of X right here, 9.8869. Now to get this second X value, we'll call this X1 and X2, I don't have to use the calculator. I can if I want to, but because I know this value right here is 9.8869, and I know that the distance from here to here between 10 and x1 has to be the same as the distance between 10 and x2 because the graph is symmetric. If I find that distance between 10 and x1, and then I add it on the other side, that will give me my second x. So that's one way I could do it. The other way I could do it is by doing inverse norm again. But I have to take into consideration, if I'm looking for this second x right here, for x2, my percentile is now changed. The percentage to the left of x2 is now 55% because I've got this 45% plus this 10%. So everything to the left is 0.55. So I'm going to put in 0.55 for my percentile. Then I still put in 10 and 0.9 for my mean and standard deviation. When I do that, I get 10.1131. So x2 is 10.1131. So if I look at the probability of something falling between 9.8869 and 10.1131, these are the values that hold the middle 10%. That probability that it would fall between those two values is 0.10. And so we did it by either using inverse norm and looking to the area to the left, or once I find one of those x's, I can just use symmetry to figure out what the other x is.